Hello everyone, welcome to our channel Academics. In this video, we are going to discuss about Thompson sampling, where Thompson sampling is a popular algorithm in reinforcement learning for solving multi-armed bandit problems. So why we are using Thompson sampling means it is simple to implement, that it is relatively simple to implement and it is also optimistic, meaning that it explores actions that have high potential for reward and also regret for minimization. Thompson sampling has been shown to achieve near optimal regret bounds. So in this video, we are going to discuss what is Thompson, what's the meaning or the origin of the Thompson sampling name, and what is sampling and why sampling is used or it is called as Thompson sampling. So where did the name came from means, the algorithm is named after the William R. Thompson, who first proposed it in his 1933 paper. The paper name is On the Likelihood that One Unknown Probability Exceeds Another in the View of Evidence of Two Samples. What is sampling? Sampling is a statistical technique, as you all know, used to select a subset of data from larger population. The goal of the sampling is to make inferences about the population based on sample data. Why sampling in Thompson sampling? In Thompson sampling, the algorithm samples from the posterior distribution of the action parameters. This sampling process allows us to algorithm to explore the uncertainty in the reward distribution and balances exploration and exploitation. Here, in this Thompson sampling, the same action may or give different rewards in different selections or executions due to change in the nature of environment. Here we can see the random value distributions of action A1 and action A2, 15, 16, 17, 10, 12, 11, 18, and so on. And action 2 values 20, 15, 18, 16, 21, 17, 45. Here in Thompson sampling, we are going to take a sample from this set of possible actions of P of A1. 10, 11, 18 are selected, and this sum of these sample is 29. In action A2, 15, 18, 16 are selected, and the sum of these rewards or actions taken is 49. So which is the highest will be taken as in this action, that action will be selected. So here 49 is the highest when compared to 29. Then action A2 will be selected. So let's see how Thompson sampling works. Here what is Thompson sampling means. Thompson sampling is a heuristic algorithm for balancing the trade-off between exploration and exploitation. And then how it works means the agent maintains a probability distribution for each action. Here you can see the same matter. The agent maintains a probability distribution for each arm or each action. And then the agent maintains a probability distribution for each action. This distribution represents the agent's current belief about the potential rewards of each action. This often modeled using Bayesian posterior distribution. Then sampling rewards. At each time step, the agent sampled reward values from each distribution. So first the agent maintains a probability distribution for each action, and then based on that distributions, he chooses the action. Based on which potential reward it is receiving, it chooses that action. It is often uses the Bayesian posterior distribution. And then we can see this example. I have already explained you an example. It is also an action A1 and action A2, where 10 and 18 are selected as sample reward values. When compared to 10 and 18, 18 is the highest one, so 18 is selected as action A2 for the next action to be taken by the agent. And then see here you can see randomly it chooses value say as 10 and say as 18, so 18 is selected. It would select the best action, so 18 is the best action. It is selecting the action A2. So updating beliefs. After taking an action and observing its actual reward, the agent updates its probability distribution for that action to refine its beliefs. So it automatically updates after taking each action. Why we use Thompson sampling means to balance the exploration and exploitation, and it is used in multi-arm bandit problems. So here we can see the same matter. Sampling is a heuristic choose for choosing actions that addresses exploration and expedition development multi-bounded problem. So let us consider a set of contexts or states. Assume that states are as context X and a set of actions as capital A and the rewards as capital R. The aim of the agent or the player is to play actions under the various context means states, under the various states such as to maximize the cumulative rewards. In each round, the player undergoes a state or a frames a context or a state where small x belongs to capital X, plays an action, small a belongs to capital A and receives a reward. So as we all know, an agent when interacts with the environment, it takes an action A when in the current state X and receives a reward based on the action it takes. It receives a reward R based on the action it takes. So it following a distribution that depends on the state and the issued action. So here are the five 1, 2, 3, 4 elements. These are the five elements of Thompson samplings, a likelihood function. It is the likelihood function P R by theta, comma A, comma X. Here A means action, X means state, where theta is a parameter and R is reward, P means probability. Where a set of parameters theta for the distribution R is also an element, and then prior reward distribution P of theta of these parameters, and also past observation triplets. Here triplets means 3, where X is state and A is action and R is reward. Posterior distribution, this is the formula of posterior distribution where P of theta by D is directly proportional to P of D by theta into P of theta, where P of D by theta is the likelihood function. Thompson sampling consisting in playing the action A star, where A star belongs to A, capital A actions, set of actions according to the probability that it maximizes the expected reward. Action A star is chosen with probability. The formula of this is here given. You need to remember this formula while writing in your exam. The rule is implemented by sampling in each reward, each round, selection of the time step. Parameters theta star are sampled from the posterior P of theta by D and an action A star is chosen that maximizes P of R by theta star comma A star. So this is new action to be taken and X is the new state. That is the expected reward when filled parameters. This means that the player initiates their beliefs randomly in the each round according to the posterior distribution and then acts optimally according to them. Prior probability represents what is originally believed before new evidence is introduced. So, in Thompson sampling, we use posterior probability, prior probability. P of A means, so we know this formula from our childhood. P of A by B is equals to P of B by N into P of A. Sorry, P of A is probability of an event A occurring, and P of B is probability of event B occurring, a marginal likelihood. And the posterior probability takes this new information into account. Probability of event A occurring that the given event B is already occurred. P of A by B means the probability of occurring of an event A, the probability of B is already occurred. Sorry, event B is already occurred. So this is all about Thompson sampling. That's it for this video and thank you.